Good morning. It's Tuesday, which is rapidly becoming our promo day. So following along the last couple of weeks, we had calc and algebra sponsor us. Today we're sponsored by geometry. All right, so go ahead and enter that promo code listed down below. Promo code, I believe, yes it is Euclid. That's EUCLID. So promo code Euclid, that'll get you a nice discount on any new geometry that you'd like to get. And don't worry, you non-Euclidean fans, I'm sure you can still use that promo code for things of interest to you as well. All right, so let's jump right in to today's lesson. Good morning. All right, so you do have an exit ticket due by midnight tonight. Otherwise, let's jump straight into our lesson. And our lesson today, again, I told you I want to go very slowly through limits. Okay, so our lesson today is just more practice with evaluating limits. All right, so we're looking at example 4 today. Evaluate the following limits. And we'll go through each of these, plus another few practice problems for you to continue to get more comfortable with this. All right, so what are our methods for evaluating limits? We can graph them. I don't know about you, but I really don't want to graph this function. Okay. After that, we try substitution. Okay, so let's try to substitute x equals 0 into this limit. Okay, now if we do that, we get 5 times 0 cubed plus 8 times 0 squared all over 3 times 0 to the 4th minus 16 times 0 squared. So 0 plus 0 over 0 minus 0. And this is undefined. That means we can't just substitute in x equals 0. That means we need to try our next method, which is our algebra magic. All right, now with our algebra magic, we take the same limit, and we already have it up here. So let's think about how we can simplify this. Okay. Now, is there any greatest common factors we can take out here? In the numerator, we can factor out an x squared. And same thing in the denominator, actually. We can factor out an x squared, and we're left with 3x squared minus 16. So these x squareds cancel. We have the limit as x approaches 0 of 5x plus 8 all over 3x squared minus 16. Now that we've done some algebra magic, we tried to substitute again, now that we're at this point. So let's try to plug in 0 for x. We get 5 times 0. And that's 0 plus 8, all over 0 minus 16, which is negative 1/2. So substitution didn't work right away. That's fine. We just do a little algebra magic. We pull out a GCF, cancel, and then we can substitute and get our answer of negative 1/2. Okay. So all of these problems work just like that. We try to substitute. If substituting doesn't work, we try some algebra magic. And if that doesn't work, at this point, we can't really do much else unless we're going to graph it. Okay. In calculus, we'll learn another method for evaluating these limits when our algebra magic fails. So we try substitution. We're plugging in negative 1/2 for x. All right, now we just need to be careful when we're simplifying this. Negative squared is positive, 1/2 squared is 1/4. 2 times negative 1/2 is negative 1 minus 1. So we have 3/4 times negative 2, which simplifies nicely to negative 3/2. So in this case, substitution worked right away. We didn't have to worry about any algebra magic. There was no issue with a domain. Okay. And yes, this should be C, not a second Letter B. My apologies. All right, now let's take a look at this. Always try substitution first. Plugging in x equals 0. In the numerator, we get 0 minus 0 plus 0 all over negative 4. Now, are we allowed to have 0 in the numerator? Yes. 0 divided by some number is just 0. That's perfectly acceptable. It's when we have 0 in the denominator that we have some issues. So remember how I like to think about this? Okay, is money. If I have $0 and I want to split that between 5 people, how much money does each person get? $0. Okay, so that makes sense. If I have $20 and I want to divide that between 0 people, what does that mean? Does the money disappear? How did the money disappear? It should still be there. Okay, so that's why dividing by 0 doesn't make a whole lot of sense. We call that undefined. But 0 in the numerator is perfectly acceptable. It's just 0. So in this case, substitution worked. All right, last practice problem in your notes. And this is the limit as t approaches 2 of t squared minus 3t plus 2 all over t squared minus 4. Now, we can try substitution. Now, we can figure out the numerator, but right away I see in the denominator that we have 4 minus 4, which is 0. So we have some number all over 0, which is undefined. So it doesn't matter what the numerator ends up being here. Could be 0, but 0 divided by 0 is still undefined. And in calculus, that's actually something else that we look for to help us with that third method of evaluating. Here, we're not taking that extra step. Automatically, we see a 0 in the denominator, so we know that substitution didn't work right away. That means we need to try some algebra magic. So this is the limit as t approaches 2 of, what can we do with this expression? We can factor the numerator, so it's going to be t minus 2 times t minus 1. And we can factor the denominator. This is the difference of squares. So t minus 2, t plus 2. That cancels. We have the limit as t approaches 2 of t minus 1 over t plus 2. Now we can try to substitute. We have 2 minus 1 all over 2 plus 2, 1 over 4. And there we go. All right. So substitution didn't work. We did a little algebra magic, and then substitution worked after that extra step. All right. Now, I have 3 more practice problems I'd like you to do. So these are in the PowerPoint that I've posted, this PowerPoint right here. So take a second, work through this problem, and if you can't see it, pull up that file, and then come back to this, and let's talk about this problem here. We'll go through the answers. So we have the limit as x approaches negative 3 of x cubed times x plus 1. First things first, we always try substitution. All right, negative cubed is still negative. 3 cubed is 27. Negative 3 plus 1 is negative 2. Multiply together. All right, so substitution worked. We got an answer. Okay, so check your work. Here's our next problem. Take a second, pause, work through this problem, come back. Now we'll talk about this answer. We have the limit as t approaches 0 of t to the 4th plus 3t squared all over 2t. Now if we try substitution, we get 0 plus 0 over 0. That's undefined. So substitution didn't work right away. We need to try some algebra magic. Let's take the limit as t approaches 0. What can we do here? We can factor out a t squared in the numerator. And now a t should cancel, so we have the limit as t approaches 0. Please, again, note when I'm writing the limit, and the only time I stop writing the limit here in front is when I actually plug in, when I actually substitute in that number. So a t cancels. We have t times t squared plus 3 all over 2. Now we can try substituting, so we don't have to write the limit anymore. I am taking the limit. I have 0 times 0 squared plus 3 all over 2. 0 over 2. Again, we can have 0 in the numerator. 0 divided by 2 is still 0. So this limit is 0. Take a second, check your work. One last practice problem. Okay. So hopefully you're getting much more comfortable with these limits. If you are, that's fantastic. You're going to have a great head start for calculus. All right, let's try substitution. We plug in 4 in the numerator for x, and in the denominator. Again, the numerator, it's going to be some number. I don't really feel like figuring that out right now, and I don't need to because right away I see that I have 4 minus 4 in the denominator, which is 0, which makes this entire thing undefined. So we need to turn to our trusty algebra magic. This is equal to the limit as x approaches 4. Let's factor the numerator. All right, that's a simple quadratic. We get x minus 4 times x minus 7. The x minus 4's cancel, so this is the limit as x approaches 4 of x minus 7. Now let's try substituting. And we get -3. All right, there we go. So make sure you've practiced through all of this, okay? And take care of that exit ticket by midnight tonight. It's just some basic questions about today's lesson. And get started on that 9.1 independent practice. You can do some of those problems. Now we still have about half of this section left. And now that we have a really good foundation of what a limit is and how we evaluate limits, now we're going to turn our attention to some more interesting types of limits. Specifically, what happens with limits that involve infinity? What happens as x approaches infinity? And what does it mean for our limit to equal infinity? Okay, these are questions that we're going to explore on Thursday and Friday. I'm very excited. Yet another step into calculus. So please come to me with any questions you might have. Take care of that exit ticket, do some practice, and I'll see you on Thursday. All right, well, that's it from me. Remember, tomorrow is our Flex Wednesday. Go ahead and pre-calc, sign up for a retake appointment tomorrow. Okay, that's at that calendar link that I've shared with you. And AP Calc, if you need any one-on-one tutoring or small group tutoring, just let me know, email me, and we'll set up a time, okay? Otherwise, use tomorrow to catch up and be ready to jump back in on Thursday.